What's up, YouTube? Today we're doing a different style of video today where we're just going over my solution instead of just taking you through the entire part, because the video's gotta be engaging, but yeah, we did this problem, minimum penalty for shop. It's Christmas. It's actually the day after. It's 12:14 a.m. But yeah, I finished first quarter, winter break now. Christmas break is going good. School first quarter went pretty good, so pretty happy with everything. But yeah, I guess I'm technically employed because I got an internship, so we're employed. Maybe that'll be the title. We got employed after doing 2 Leetcodes. Alright, that's a thumbnail. Sorry, but anyways, yeah, we did this question. It took me, if I'm being honest, 45 minutes. Loki took me a while, but look at this runtime. 6-7. Alright, sorry, but yeah, it took me like a couple submissions, but it went fine. So yeah, let's just go through this and we'll see. So basically, let me explain the problem to you so that shows my understanding of the problem, So we're at a shop, right? And the shop has like a string of customers, right? And the customers represent the visit. It's like a visit log. So if it'll be a string of yes, like Y and ends. And then basically if the ith character is a Y, then that means the customers come in at the ith hour. And then N is obviously they don't come in. So if it's open and no customers come, the penalty increases by 1. But if it's closed and the customers come, then the penalty increases by 1. So it's like pretty logical, right? So return the earliest hour which the shop must be closed to incur a minimum penalty. Okay, so it took me a really long time to just calculate it, but let me just walk you through it in case you want to do this or something. Okay, so if it's at 0, if it closes, the shop closes at the 0th hour, so that means it's closed, like right here. Okay, so it's closed at the 0th hour. Are the customers at 0? Yes, right? So that means we want to add that to the penalty. So it's 1 plus, and then everything else is closed. So it's plus 1, and then no. So there's no customers who come in at this hour. So since it's closed, we don't incur a penalty because it's closed, right? And then we incur a penalty there. So it's 3. So the first iteration is just essentially how many Y's there are. And then going to the first hour, if it's closed at the first hour, we see, okay, if it's closed at the first hour, then that means it's open for the 0th hour, right? So it's open and it's a yes, and there's customers coming, so we don't incur a penalty, but everything afters, we incur penalties, right? So a yes, it's the same process. So since it's closed at a Y, we get plus 1. It's closed at a no, so it's 0, and then close at a Y, so it's plus 1. So in total it's plus 2. And then same thing for here, we just calculate these two would just be 0, 0, because they're open, and then here they're closed, so it'll be 0 plus 1, and then here it's just, wait, if they're closed at the 3rd hour, then it would incur, this one's a little different because it's open for this like 3rd hour, I guess, or for the second hour. Then since it's open and there's no customers, we incur a penalty because they don't have to be open, they could just close earlier, right? So that'll be a plus 2. And then if it's closed at the 4th hour, it would just be how many no's there are, if that makes sense, right? So yeah, that part alone took me just like 10 minutes to understand. It was really weird, but yeah. Then so my approach to the problem, this is just like, if you just solve for this, you solve for this, right? Those are pretty easy to walk through. But yeah, since 2 is earlier, the optimal closing time is 2, but we could just solve that with the less than sign instead of doing less than equal. But then, okay, you're the interviewer, I'm the interviewee. So let me explain this solution to you. First, we're gonna keep track of this thing called total sum, right? Okay, so what we're gonna do is, so my intuition, first of all, I wanted to traverse through the customers and see how each character in the customer string would affect the penalty. Makes sense, right? Approach, calculate the total penalty, right? So as I mentioned earlier, the total penalty at the start, this very first one, is going to be how many yeses there are, right? I mean, I guess you could do it with how many no's, but I just thought it was more intuitive to do with yes. So literally just did a for loop, right? Counting how many yeses there are. And like, by the way, by no means is this like the most efficient. I saw like a O of 1 solution, like one. There's always some BS one-liners, bro. There's like O of like 2 n, like whatever. I'll take it. Like 6-7%. All right. So yeah. Now, where did I leave off? Okay, here. Okay. So yeah, as I mentioned, O of 1 solutions, but yeah, we'll take 2n. Let me just explain with this because I'm so proud of it, right? So we just counted it. So now we have a total penalty, right? And then we just set our minimum equal to total because, I mean, that makes sense. Because like after the first one, our minimum is just the third one, like 3 penalty, like if that makes sense. So in terms of our traversal right now, we're like starting from here. So we're starting from the first hour because I mean, we already did the 0, so it'd be redundant, which is why we started at 1 here. So now this is step 2, iterate through each possible closing time. So, I mean, we're just doing the rest of those, so obviously we have to iterate through. So I mean, that's the only solution I saw, like O of n. So yeah, create local penalty to calculate the penalty for that closing time, right? So I'll explain a little later, but it's just basically just to keep the minimum. I keep track of the minimum. And then, so here's the key to the problem. I found out that if the previous, not like I found out, like I researched some discovery, like I noticed that if the previous hour's customer was Y, then you subtract 1 from the penalty because you have to add back from the iteration before. But then if it was the previous was N, then you should have closed it earlier and thus get a penalty. So this was what I was kind of mentioning with this, what is it? This like look at this one, right? So let's say close it at the 3rd hour, okay? So before we were at a 1 penalty, right? So by this point, our min penalty would be 2, or would be 1. I didn't really explain the code, but like intuitively it's just 1, right? And our min index right here would be 2, right? But like when we go to this next iteration, what's gonna happen is that we close at the 3rd hour, which means we close right here. So it would be open for these first, technically, I guess like 2 hours, right? It would be open until the 2nd hour, but it should not have been open right here, right? So because of that, because of the previous one, it should have been closed before. We need to add 1 to the penalty, which is how I figured out this part, right? So how did I figure out this part? Well, I just looked at the first ones, right? So we found out this 3 penalty total, right? It's how many Y's there are. But then this one, well, intuitively, we closed it at the 1st hour, right? But then we kept it open for the 0th hour. Like, you know what I'm saying? So because we kept it open instead of closed, we need to subtract 1 from the penalty, right? Because in the previous iteration, it was closed, but now it's open at the 0th hour, right? So that's why we have to subtract from the penalty. And then this is just a simple minimum calculation. And then, yeah, that's just step 3. Yeah, as I mentioned earlier, it has to be less than instead of less than equal to, or else we'll do something like set it to 4 instead, but we should instead close it at 2 since 2 is earlier. But that's just like a little thing. And then step 4, set total penalty equal to local penalty outside of the if. That's something I got tripped up on for a little bit. And yeah, that's because essentially what we're doing is keeping track of everything before it. So if we're at like the 3rd hour, let's say, right, we're closing at this one, we kept track of these ones, like, and then we're just determining like the previous. So every time it should be like notice how it doesn't change by like more than 1 because we're just doing plus or minus. And then so like here we just went down 1, up 1, down 1, because we're keeping the total penalty equal to the local penalty every single time, regardless of whether it's a min or not. We just want to keep the total penalty equal to the local penalty because we need to keep track of it, if that makes sense, because it's a global variable and then this is just local, which is why I just called it local. But hopefully that makes sense. And then return the min index. Yeah, just return at the end. time complexity, open, space complexity, outer space. But yeah, that's my solution. We're gonna upload it. But yeah, oh, can I edit it? Dang it, I can't edit it. I want them to follow my YouTube channel. Yeah, sorry guys, I haven't uploaded, but yeah. But yeah, I mean, I guess we got a job. Challenge over. I don't know, but I might start doing some other forms of content, like day in the life, you know, maybe just some like short form, like, oh, this is what my day is like at Stanford, blah blah blah, or like something like that. But let me know down in the comments what you guys want to see, and yeah, I'll see you guys next time. Merry Christmas.